Well, welcome back to another episode of the Atlas Foundation podcast. My name is Emily, and I'm here with Mike Moeller yet again. And today we are going to be discussing everything under the sun about helical piers. And I will let Mike take it away.
Well, thank you, Emily. I appreciate the time to talk about the subject. Um, Atlas Foundation Company started installing helical piers back in the 1980s. And the thing is, that was kind of a relatively new installation method and type of deep foundation back then. And we have kind of worked through a lot of the kinks and developed ways of doing things. And now our crews are very efficient. I think some of the most efficient um, installing helical piers in the country. And one of the biggest complaints I get is that the crew was only on the job site for 2 hours and they completed all the installation and left. How can they do so much work in such a little amount of time? But the fact is, they know what they're doing, they get it done, and they don't waste time. So um, it's nothing to see our crews install 20 helical tiebacks in a day. That's fairly common. So it's it's funny when you see other construction companies, watch what our crews do, and then they think, well, this is simple to do, so they basically secure a job and they go out and try to complete an installation, trying to keep up with our type of schedule, and kind of pretty much fall flat on their face. And the owner is, not happy when the job doesn't get done. So it's interesting to see how things have evolved.
Sure. Well, thank you for that introduction. And maybe you can just kind of briefly touch on the difference between helical piles and then just the traditional driven piles.
Sure. uh, Atlas Foundation Company actually started out in 1968 as specifically a driven pile contracting company. As far as I know, we're the only production piling company that has completed projects of over 1 million feet of piling in the upper Midwest area. But shortly after getting started, we quickly developed other systems, caissons and helical piers, and micropile being some of the other ones. Um, Helical piers different from driven pile in that they're screwed into the ground rather than being just driven into the ground. So it's really kind of cool. Um, what's developed over the years is that the installation torque of a helical pier is proportional to the ultimate capacity. So we use that proportionality to the ultimate degree. So we have um, all types of different machines that use the hydraulics on that machine to install helical piers. And we have different types of torque heads that transmit the installation, the hydraulic pressure into installation torque to install the helical piers. So on an annual basis, we calibrate all the different torque heads with the different machinery so that we know exactly what hydraulic pressure correlates with a given installation torque, and that equates to an ultimate capacity. So we have gauges in all our equipment to tell the operator what the hydraulic pressure is. So before he starts on the job, he knows what capacity he's trying to achieve, and he knows what pressure he has to get to develop that capacity. So it's almost a foolproof system that is quite a bit different than driven piling. With driven piling, there's more. Typically, there's a pile dynamic analysis that's done to determine what the capacity is, and then pile driving criteria is established, so many blows per foot to achieve the capacity that's required. So with helical piers, it's a little bit of a simpler process, and it's almost foolproof. So it's uh, it's really wonderful that way.
Sure. And what kind of, just kind of going into some of the typical applications for helical piers, what are the specifics that go into, what projects use helical piers?
Well, helical piers are becoming more and more useful in everyday life and construction. Uh, some of the big reasons is that probably the big one is it's very economical. It's probably about half the price of micropile. Generally, for the smaller loads, it's generally cheaper than driven pile, and obviously cheaper than caissons. So it's a very useful product, and it can be installed uh, vertically, horizontally as a tieback, or just about any range of angles in between. So, and some of the advantages are that there's no noise or vibration installed or associated with the installation process. Fairly small equipment can be used, so headroom is usually not a problem. It's just a very versatile type of um, you know um, application, so that it can be used in a variety of ways.
Okay. And what are some, specific examples of, certain buildings or foundations that would use helical piers?
Well, in there, if you've got low headroom conditions or um, problems with noise or vibration, those are dead giveaways. It's a perfect spot. Um, some other conditions would be if it's if you need say like a tieback installed. um, Generally helical tiebacks are um, obviously more quicker than grouted tiebacks, and very efficient. You can load them up and test them immediately after installation. So there's quite a few places where the helical anchors or piles will solve a problem very nicely.
Sure. Okay. And because I know that Atlas has done, or used helicals for, small residential properties and, even boardwalks or decks, smaller projects, but then also bigger projects. Am I right?
Right,
Yeah.
right, yeah. Um, we've used them for applications that probably nobody else in the world has ever used them for. We've used them for large thrust restraint applications. Uh, we've we've completed jobs where the thrust restraint load at a joint was over 950 kip. So, and actually on those jobs, we've had to prove that we've got that capacity with the load test. So, but all types of, like you say, tiebacks, new construction, building support, settlement, underpinning. We've done underpinning jobs with not only residential but uh, you know medium-sized commercial buildings, apartment buildings, uh, some actually fairly heavy structures, and then obviously tiebacks. Um, Basically, there's so many applications. I don't think anybody has come to the a situation where you've run out of places where they can be used.
Sure. And I think, is it safe to say that Atlas Foundation is one of the leaders in at least the Midwest when it comes to helical piers? I know there's some fun facts about certain jobs or whatever. with helical piers, but is it safe to say that Atlas is definitely one of
Yes.
the, yeah.
Yes, our crews are some of the best in the country at installation of helical piers. Not only efficient, but the quality of the installation is, I'd say, top notch. We're also a distributor of Chance helical piers. So we cover about 9 states here in the upper Midwest where we sell the Chance helical piers to other contractors.
Okay, awesome. And are there certain examples where we have used helical piers that may stand out from other companies that have used helical piers, where we've either set records or completed a project that nobody else really has?
Yes, definitely. Quite a few jobs. There are jobs that we've done with some uh, customers up in northern Minnesota where we've faced some challenges, let's say, on the installation. Um, there are cases where we've had to install, I believe, over um, 500 helical piers in you know in within a schedule of 1 week. So there's been situations where we've uh, been highly successful in situations where it was quite a challenge.
Sure. And then just kind of going into some design considerations when it comes to helical piers, soil conditions, load types, that kind of thing. Can you just kind of talk a little bit about that specifically?
Certainly, being a partner with the Chance helical pier industry, we use their software, which is um, basically allows us to take a given soil boring and install a given helical pier into that soil profile, and uh, tells us what the capacity would be at different depths and different conditions, different helix configurations, and that type of thing. So, um, one thing to keep in mind with helical piers, uh, basically, if you're in a sand, a, a good part of the capacity is developed from friction. So the overburden pressure, the weight of the soil above the helical pier, the helix plates, is what determines what the capacity is. So a lot of people don't realize that when we have a, an installation in a real sandy environment, and say the water table is down significantly over the normal situation, and over time the water level raises, that will actually decrease the capacity of that helical pier. So we actually take that into account in the design procedure um, so that there's no problems down the road with our installations.
Sure. And then can you maybe just walk through the installation process and what that looks like with Atlas?
Sure. Um, once we've got the design and the say like for a new construction project, and once the basically the area is excavated to the bottom of concrete, our crews will come in and kind of work through the site and and install helical piers, kind of down the row. They'll start out um, installing them down to the torque and the depth that's required. And with each one, they'll compare the adjacent depths and capacities to make sure that there's no problems or surprise situations with the soil conditions, and basically just work through the job site um, in a fairly efficient process.
Are there any like field challenges that tend to come up where our crew has to work around it, or what kind of things do they run into commonly?
Sure, Emily. There's all types of challenges that the crews come into or come up against them. Um, One of the big challenges is boulders or rocks or cobbles that they'll run into during the installation process. We have our secrets that I probably don't want to get into too much, but basically it allows us to kind of work the helical pier around the rock or something like that. Some other challenges are access. Um, a lot of times there's, say, like on a tie back job, a lot of times we'll have a steep slope that we're trying to work around. So a lot of times it's fitting the equipment with the site. So um, it's tries to keep us out of trouble and minimize problems and um, make the job outcome come out as best as possible.
Sure. And then going into just kind of the advantages and also the limitations to helical piers and just kind of that whole that process of using them. Some advantages, I have written down here: rapid installation, minimal vibration, which you mentioned earlier. What other advantages are there to using helical piers specifically?
Well, you hit on a lot of them. You know, economically, they're probably one of the most suitable for fairly small loads, less than 100 kip design capacity. Speed of installation is basically second to none. As far as probably the next competitor would be Micropile, and uh, obviously we can do the helicals quite a bit quicker than that. Um, some of the disadvantages would be a limitation in load capacity, especially in certain sites, um, that type of thing. But um, that's the reason we see helical piers being used more and more. It's such a simple process that generally um, easy to come up with a good outcome.
Sure. And, just kind of touching on the limitations a little bit more, when it comes to, soil conditions, are there any challenges that come up with that where helicals might not be the best option?
Yeah, I'm glad you brought that up. As part of the Chance family, we have what's known as a pull down micropile, where we can install helical piles with a column of grout around the shaft. And that helps in a number of ways. It prevents buckling of the shaft. And that's one of the big Achilles heels of the helical piles, is that um, when the load is applied and the soil doesn't provide the confining pressure, in the Chance design manual, that calls for a soil that's less than 3 blows per foot. So say that you're in a organic layer that extends for some distance, some length. uh, you're if you're just putting in a straight bare helical pier, a lot of times um, that that shaft can buckle because the length over the section modulus is such that it doesn't have the strength without the confining pressure of the soil. So that can lead to early premature failure.
Okay. And what about also, corrosion considerations? Is that ever, something that you run into?
Well, it's generally should be part of the design process. Chance helical piers are generally hot dip galvanized, so that's pretty much the best treatment for corrosion resistance. But it's good to look at the soil conditions and analyze what the life expectancy would be. Uh, Generally, all our installations are designed around a 50-year design life, but the last corrosion analysis that I did for helical piers, I think I came up with it was over a 200-year design life. So, and that's the length of time where the helical pier would have the design capacity due to corrosion.
Sure. Wow, that's kind of crazy. And I might be putting you on the spot here a little bit, but is there a specific job or, multiple jobs that come to mind where using helical piers specifically kind of saved the day in essence, or um, kind of made the project go quicker, or, that kind of thing?
Certainly, yeah. There's I remember quite a few jobs that come to mind. We did one big apartment building that had settled significantly because it was discovered that there was an old kind of a stream bed that ran right through the middle of the structure. Um, the problem is with access. Um, the the building, it was a big apartment building, only had a crawl space. So um, we asked our crews to install fairly deep helical piers for underpinning that structure from inside of a crawl space where you only had 4 or 5 feet of headroom. So that was expecting a lot of the crews, and um, but they did an excellent job, outstanding work, and we were able to lift that structure back up to where it was significantly closer to being level than it was before, and made it quite a bit more functional than it was. So it was definitely a win-win for everyone.
Sure. Well, that's awesome. Are there, what kind of misconceptions might there be for helical piers themselves, or even just the installation process of the helical piers?
Well, one of the big questions I get is help me design helical piers for this project site. And so I ask, well, what are the soil conditions? And they say, just ordinary soil conditions. So that becomes kind of problematic for me. Every soil type reacts differently, and it's best to know the specific soil conditions for the the project.
Are there any doubts when it comes to load capacity, specifically when it comes to helical piers?
Well, there's um, a lot of times there is some question. Our software is generally on the conservative side, and there are times when we will, even though the software will tell us that we could be not able to generate the required load capacity, so we will complete the installation and do a load test. And many times this works out positively, and of course, everybody is happy that the loads are achieved, and the project is successful.
Sure. And I have some common engineering questions here for you. The first one being, how reliable is the torque to capacity relationship?
This is a very reliable correlation. In fact, it's one of the most reliable correlations in the deep foundation field. This has been uh, uh, collaborated by a number of investigators that have compared load tests versus um, trials with just doing installation torque correlation method. And I don't remember exactly um, what the specific correlation is, but generally, when we're installing helical piers in, say, like a sandy soil, a fairly clean sand, um, for a square shaft, we use the K sub T, which correlates the hydraulic pressure or the installation torque to the ultimate capacity. With the sand, generally, with the square shaft helical pier, we're looking at about a 14 um, to compare the two. And with the clay, it can be probably generally a low of about 10.5 or something like that. So we generally, with square shaft, we use the K sub T of 10, which is conservative. So we know we're leaving a little bit of capacity kind of that's extra built in. So we have a little additional safety factor, especially with the sandy type soil. But when we get in some problematic type soils, using the 10 keeps us safe. So
Sure. Okay. And how are helicals designed for uplift loads?
uh, the design of helical piers is basically the helix plate bearing on the soil. So the crazy thing about helical piers is, um, in compression they bear on the soil down below the plate, but in tension they bear on the soil above the plate. So it's actually fairly close, in as far as a capacity in both compression or tension with most helical piers.
Okay. And then the last question here is when should helicals be avoided?
Well, like I said, the biggest bugaboo with helical piers is buckling. So um, the designer should watch buckling as kind of one of the primary considerations. So when the installation is in a soft or very loose soil with a N value of less than 3, buckling should be a very um, prime consideration. And um, unless there's a method to control, the buckling, helical piers should be avoided in that type of soil.
Sure. Okay. Well, awesome. Well, is there anything else that you'd like to add to wrap this up? Nothing?
I can't think of anything, Emily. Thank you very
Perfect.
much. I think it's in summary, helical piers have become a tried and trusted and true method of deep foundations that we are very confident in. Um, at Atlas Foundation Company, we like to be able to sleep at night, and we are very confident when we send the crews out to do any job that we have looked at and designed. So it's nice to know that we've got a good system.
Sure, absolutely. Well, thank you so much. That is all that we have for you today. Stay tuned for other episodes. And if there are any specific topics or things that you'd like to hear Mike chat about, just let us know. And as always, find us on social media, Instagram, Facebook, LinkedIn at Atlas Foundation Company. And then also, if there's anything, job related or specific to that nature, head to our website at atlasfoundation.com, and there should be a submission form on the website there that you can send in. But as always, thank you so much and have a great day.